Hello, my name is Abdullah Musalli, and in this presentation, I'm going to be presenting my work, which is a joint project with Muhammad Afifi. This is our final project for the IT class for Dr. Chang, and our project is about stock market forecasting analysis using different probabilistic and machine learning models. So, in this video, I'm going to be talking about the part that I did in the project. My first part was to collect economic indicators. We determined to collect unemployment rate, monthly rate, and price index per month. We believe that these indicators will have big influence on predicting the longevity of the stock market when we want to make a long-term investment or so we want long-term prediction. Uh, I'm gonna be showing the notebook where I did the unemployment rate. So we got the unemployment rate using the Quandl library, which it has a lot of dictionaries inside of it. The unemployment rate is from the FRED, which stands for federal something, and it updates monthly. So I did some analysis on the unemployment rate. We only use this unemployment. However, the unemployment rate is not only this part. And we used the data, and here I only plotted the data for 2020. But in the project, we used data between 2015 and 2020. As we split the data from 2015 to the end of 2018 as a data so we can train on, and the test was between 2019 to the end of 2020, December 2020. So I did analysis on unemployment by race, which are all data sets or databases reported by the federal government. We can see that the most unemployment rate, we can see a significant increase in unemployment rates in the month of May, which is like between April and May, which is like when the pandemic hit the hardest and like job closed. You can see that the Hispanic people were the most and the black community were the most affected by that unemployment. We can see that women were affected more, were laid off more than men. And when we plot the race and gender together, you can see that the most people who got affected were the Hispanic women. When we look at group of ages, you can see that the people between 20 and 24 are the ones who got affected the most. As we can see, between April and May, the sharp increase in the unemployment rate happened, which tells us that people who are with low experience or like just startups in their jobs in their positions got affected the most. And by education, we can see that the people with lower than high school got affected the most, while people with PhDs basically had zero to no effect on their unemployment status. So I also did some analysis on consumer price index. We have the federal government releases a lot of price index data sets as well, updated monthly, like for food, for the consumer power for food, for cars, for insurance, for rentals, for healthcare, for a lot of stuff. And let's go back to the presentation. And the second thing that I did was to build a model to analyze the news of a stock, which the goal is to forecast future trends of a certain stock. by using the a news headlines. So we have sentence, and each headline or sentence is going to be classified as either bad news, which indicates negative score, or zero, which indicates neutral. Not exactly zero. We can set that like a threshold between like minus 0.5 or like minus 0.1, just 0.1. We can determine neutral, and positive, which determines good news, which indicates that the stock should be going up or is going up at the moment. When trading, especially for a lot of stocks that run on news, such as stocks like who have big news like Tesla or vaccine stocks, mRNA, Pfizer, or AstraZeneca. So keeping up with news is very, very important, as the moment the news hits, there's a huge increase in in the price of the stock. And the goal is actually, if in the future we want to do an API, where we can connect this model to an API for like Robinhood or any other brokerage, where we can uh, connect uh, the news sentiment where any like good news come, so we instantly initiate a buy order or a stop buy order or a stop limit order. So the to use this, we don't have any access to any paid APIs which give like large historical data, or uh, so we use the free FinaFizz version. It's one of the most famous stock websites and APIs. It has a lot of services. It provides last 100 news headline for each stock for free. We use that. We analyze these headlines using Vader, which is the valence-aware dictionary for sentiment reasoning, and it relies on a dictionary of words where these words are trained, maps the features with each score. So for a bad word, for example, drops, it has like a score value of minus 0.5 or minus 0.7, depending on the severity of the negativity or the severity of the positivity. Uh, and it gives for each word three scores. So let's say we have a word bad, and so the bad word will be like minus 0.5 for negative and 0.0 for neutral, or like 0.0 for positive. So the overall score is minus 0.5. And the Vader Dictionary contains words for stock news, which is one of the reasons why I chose to go with this analyzer, with this sentiment analyzer, not to pick other NLP libraries or which are available on for Python or for other programming languages. So it's really easy as well to update new words. Just we can make our own dictionary and set our own scores for the words we need, which we really need for biostocks, for example, because biostocks has like words that, like for example, the STIs, I think, for name of the vaccine, or a company, or like stages in vaccines, or like words that usually a dictionary for sentiment analysis won't include. So it would be really helpful if we can include such words, and it's really easy to do with Vader. And before showing the news, it can be good to show part of the codes as well. So here's a number of codes on that. These are the new words that I updated. For example, jump, for when a stock jumps or when it drops, or like beats. For example, things like it beat, it predicted earnings or stuff. And I really want to show here how it really performed well for a stock. famous that runs on news, which is RNE, Sorrento, usually small vaccine stocks that small market cap, they have small market capital, they just go as the news go and drop as the news drop. They don't have any actual resistance that if it drops, like for like big cap, as we remember when the AstraZeneca vaccine did not work, when it dropped, it did not drop more than 2 or 3% because the resistance is so high as the capital, the market capital is so high for such companies. And yeah, we can see how this doesn't perform well at all for stocks that don't have updated news daily. For example, for Tivo, the last 100 news, we had to go back like 3 or 4 months to get the last 100 news, which is like predictable that it's not gonna perform well when we don't have a lot of news. So for famous stocks, let me go back to other one, this one again, not this one, yeah, this one. So the reason we chose these stocks, the stocks that we chose, is basically because these stocks are big market and like very famous and has high value. So a lot of people use these stocks, trade with these stocks. So a lot of news comes from these stocks. For example, here we can see the Tesla news, and here we can see the Walmart. And I think in this I included Disney and Walmart as an example of how the model worked, as we can see on 26th of October, no, not October, November, I'm sorry. It predicted that there will be stock, the price will go up, and we go in 27, and we see it's a huge, like, go up. We say huge, but it might not be that good. Like maybe this is like 1 or 1.5 or 2%, because like these stocks usually don't jump, yeah, except for Tesla, it like jumps like 7% and drops 10%. And this is for the Walmart. That's what I was talking about. So when we get bad news here, see how this huge drops. So when we have like a real-time API, maybe when the bad news come, the bad news come, we set it to connect to, as I said, a Robinhood API or like a Webull API, so it can sells automatically. And as I said, uh, the next step I did for as my part in this project, I did an investment portfolio analysis and optimization. So investment portfolio is basically how much percentage we want to invest in each stock. Let's say we have $10,000, so, and we have 10 stocks we plan to invest in. How much money or how much percent from that $10,000 I need to put in each stock? And analyzing the historical data gives us like an idea on how to go for the future. So we used the data between January 2018 and December 2020 to analyze that data and determine if we want to invest now, what should be the values that we're gonna, the percentages for each ticker. So we created a portfolio consisting of 10 of the suggested companies, as the companies that we mentioned, and each has equal percentage, 0.1, like 10%. First, I'm going to start with some analysis and some terminology. First, the expected return. It's a measure of the center of distribution of the random variables is the return, basically how much return we're expecting in percentage, like 90%, like as here is that we can see 0.9, which is 91%, and portfolio volatility, which is the degree of variation of trading prices series over time, which gives us how much the stock is actually volatile. So this means like if it goes up very high and then drops back really low, and like Tesla, for example. Sharp ratio, which is it's used to understand the return of an investment compared to its risk. The ratio is the average return earned in excess of the risk-free rate. By the way, the risk-free rate is uh, it's given by the Treasury bill, the government by a federal Treasury bill, and that it's like monthly or 3 month based, 6 months based, 2 year based, which I think for the last 3 months was like 0.08% or something. And yeah, and depending on our portfolio, this is what we get for expected return, which is 91%. If we want to have a portfolio like expected return for the future, we and our volatility is like 46%, which is pretty much high because we have a lot of like volatile. Like I would assume like Tesla and maybe as PFE, Pfizer is doing a huge part of that. Sharp ratio is 1.79. And another analysis I did was to get the buy sell signals based on moving averages. And we can have like 5, 10, 50, 100, or whatever like interval we pick, whatever value we pick. And here we can see based on each 5 or 10 for Pfizer, for example, you can see the buy sell signals based on these moving averages. We can see like here, like after a huge drop, like say to buy, then goes back to an initial. Basically, it's I think it's the same value here, or like a little bit over says sell, and we can see like this is a good sell signal as well, very good sell signal. This is a good sell signal, and after that, after analyzing, I looked at portfolio optimization methods. So these percentages, how can we decide these percentages actually? Is it something like there are methods to decide like instead of splitting 10, 10, 10%, can look at the historical data and decide, okay, so this stock did better in the last 2 years, so we can give it like more weighted percentage than 10% maybe, or this stock did bad, so we can drop the percentage. So there are mainly two methods I did here, and there are a lot of methods online as well. So the first method is the efficient frontier, where a set of optimal portfolios offer highest expected return for a defined level of risk, or lowest risk for a given level of expected return. So we have here basically for each method, which is the first method, the efficient frontier, and the second method is the Monte Carlo simulation. And for each one of them, we have either optimum portfolio based on minimum volatility, or optimum portfolio based on maximum sharp rate, which takes in mind like I want the best return I can get for like low level of volatility. So this is the result of the efficient frontier for minimum. I think, yeah, for minimum volatility. As we can see, the volatility is around 0.33, which is 30%. Risk-free rate, as I said, it's determined by the U.S. and these are the number of the days, trading days in these 2 years. Something like very close to 2 years. And this is the optimum portfolio based on the maximum Sharpe ratio. So how the alignment should go for minimum, or the allocation should go for minimum volatility. We can see that it says that don't invest in Apple, don't invest in JPM, put a little money in Tesla, put big amount of money in Walmart, and 10% at Disney. 23% at Pfizer, which is weird in my opinion. Pfizer is like, I don't know, I think it's high risk. And it says put 27% in AstraZeneca, which is good because AstraZeneca is like really low risk. And for the maximum Sharp ratio, uh, we see that it says put 40% at Apple and then another 50% at Tesla, which they are both volatile stocks, but high return, high risk, high return stocks. Especially Tesla, it went up 1 year, it went up like 2,000% or something, but it's really risky. And 10% in Walmart and basically zeros for the rest. So if we look at the plot of the optimum portfolio, this is the green one represents the optimum portfolio for the minimum volatility. You can see how it's going around Microsoft, Disney, GPM, and Apple. For maximum Sharpe ratio, it's basically going to Tesla mainly. And the second method for the optimization that we use is a Monte Carlo simulation, which is pretty much brute force we saw in our projects that was given as in our homeworks. Just loop, repeat the experiment for like a big number of time, and then pick the optimum one. And after that, to compare the results we got from our probabilistic models, I was curious to see how machine learning classification algorithms would work. So we used the same data set, the same features that we used for probabilistic, the same setup to classify the trend, either go up or down. We have 21 feature, like volume, IQ, Bollinger up, or Bollinger down, moving averages, 10, 50, and many more features. The classification methods that we used is the naive, support vector machine, logistic regression, the neural network, simple neural network from the NLTK library, the k-nearest neighbors, the gradient boosting classifier, the decision tree, and random forest. First, checking the correlation between the features is important to see how these features are correlated together. In my opinion, I didn't see anything wrong with this, but still a little bit too much complicated. And let me check the part. Yep. So this is the confusion matrix for the correlation. I didn't see much difference, anything that I need to throw out. And yeah, so we can see like the best classifier was SVM with 51%, and the rest were like we were around 45, 46%. Everything was really bad in general. And I saw, when looking at the confusion matrix for most of them, I saw a lot of them were just identifying zeros. For like, I define everything as zeros. They're not identifying ones, they're not defining ups. I don't know what's the reason for that. Maybe something wrong I did, maybe correlation is wrong, maybe I need to take out some features and like study the features more. I don't think there's something wrong with the scalar. Maybe it's just performed bad. Wasn't able to predict. I definitely need to recheck these algorithms and recheck the features and see like how the features are being used. And as you can see from the table, all classifiers performed poorly, with SVM being the best with 51% score accuracy on the classification. Some of the features used are much less important. Maybe the coefficients. We need to add coefficients to each feature. We need to add weights. Uh, Definitely the further analysis can be done on this. So here's the feature importance using the logistic regression coefficients. You can see that unemployment is the most important. For me, it's quite strange because it shouldn't be that much important. Then again, we're predicting for a year, then so maybe this is the most important thing. MACD is important, which I agree with, and this value, which represents this value is very important as well, which represents if it's positive, the stock should be up, negative, the stock should be down. So for these two values, I agree that the feature importance should be more than the other two values. And for the rest of the values, we can see like the feature importance analysis from this doesn't show anything wrong. How the coefficients are being given. Maybe there's a problem with identifying the zeros. Definitely need to recheck that. So when I saw how machine learning classifiers performed poorly on classifying either 0 or 1, so I wanted to treat this issue as a time series. There are a lot of LSTM time series models for like people who try to do time series on stock with LSTM to predict the stock price, not a trend, but this time series, not classification. So uh, determining actually the structure and the optimal hyperparameters or just through a trial, just tried and like look the best look back was like 60 days, and I saw a lot of people using 40 to 60 days as well. We used 18 feature here because we had to drop a closing, adjacent closing volume, and I saw people doing this mistake online because like it's data leakage from the train to the test. Basically, it's looking at the value and predicting. So I have so many like models online with like 94% or 95% accuracy, and this accuracy is not accurate at all. Like using this approach, we were able to achieve around 70%, and the most was for Apple, 76% LSTM. In general, GRU and LSTM were very close to each other. GRU was slightly better in some cases, as I recall. As I said, this 76%, it's premature to say that it's valid or it's 100% accurate. Maybe I did some mistakes in the modeling as well. Maybe I shouldn't include some of the features I included, which like cause data leakage or cause like overfitting. So, but the results that we got were pretty near the probabilistic modeling, the Bayesian model that my team member Afifi used. This a graph represents the training and validation loss. So after using cross-validation, you see the GRU train and test were a little bit better than the LSTM, but uh, as we can see, there's like a huge drop. Then maybe it go back up again. Maybe it seems like it's being overfitted so much and like adjusting. Maybe this is the drop uh, feature. So the conclusion, real-time stock news, sentiment trend analysis model showed us that the model performed good on mostly all of the suggested tickers, performed better on news that run on stocks or on tickers that run on news, especially the bio companies with a small market capital, performed bad on companies that don't have a lot of news, daily news, and have a lot of days with no news at all. The project also showcased importance of analyzing and optimizing the investment portfolios using optimization methods such as efficient frontier and Monte Carlo simulation to pick our best investment portfolio based on the historical data we had that between 2018 and 2020. And classifying stock trend using machine learning methods were significantly worse than using the probabilistic modeling techniques. This can be due to just it being performed bad, or it may be an issue with my data preprocessing or like my teacher preprocessing. And as when we approach this modelable LSTM, we were able to improve this percentage to be better, or like some kind of around the probabilistic models that we have. And that's all for me. Thank you very much.